So remember that the whole reason why we decided that we probably needed to have logarithms was because when we have things that have exponentials in them, there is no way to undo those with any of our other previous algebra stuff. So we have to use logarithms to help us out with that some of the time whenever we're solving. Now, I will say the first property that we prefer to use is our one-to-one property. And what it tells us is if I have two things that have the same base, so like if I have b to the x equals b to the y, so those two bases are the same, then we know that the only way that this equation can then be true is if our exponents are also equal. So this is helpful when either we're given stuff that already has the same base, or if we can rewrite our numbers as the same base. Now this also works if I have a logarithm. So if I have log base b of x, and that equals log base b of y, then we also know that our stuff on the inside of our logarithm must also be equal. And like I said, we want to try our one-to-one property first because it's way more straightforward. However, there are going to be some things where we cannot use our one-to-one property. So that's where we then instead apply our inverse property. And what our inverse property tells us is that if I have b, and in the exponent I have a log base b, those two things undo each other so that I just get x. Or vice versa, if I have log base b of b to the x, again, those two things undo each other, and so I'm just left with x. So just like sometimes we'll take the square root of both sides because we know that squares and square roots are inverses of one another, we're going to take logs or exponents of both sides because we know that those are inverses of one another. So far, so good? Okay. So we have some different problems here. These are some exponent ones to begin with. So looking at my first one, I have 4 to the x plus 3 equals 16. So which one did we say we want to try for first? The one-to-one property. So I don't want to just like start by taking logs of stuff, because if I can use that one-to-one property, that's what I want to do. Now, right now, do I have the same base on both sides?
No.
No. I got a 4 and I got a 16. Those are not the same. However, could I rewrite one of those to be the same? Yeah, what can we rewrite it as?
4 squared.
Yeah, I can rewrite a 16 as a 4 squared. Now, be careful that all we are doing here is rewriting, okay? When I'm trying to find the same base, I just rewrite what is already there. We do not try and like square things. Because if we squared things, I would have to square both sides. So like, yes, your 4 would become a 16, but then you would also have a 16 squared. So that doesn't help us. So we don't want to square both sides, we just want to rewrite what we already have. Do we all kind of see what I'm saying there? Alright, now do we have the same base?
Yes.
Yeah. And so if I have the same bases, what do we also know?
The exponents are equal.
Cool. And is that a much nicer equation to solve? Yeah. So how do I solve for x there? Subtract 3 and we get negative 1. That's my answer. Yes, no, maybe. Do we have questions on that first one?
Yeah. What happened to the 4s?
So I'm using the fact that because my 4s are already equal, yeah, the only way then for this equation to be equal is if my exponents are also equal. So if we're just using this first one that I talked about. So like if my bases are the same, the only way that this equal sign works is if our exponents are also the same. Other questions?
So we just drop the exponents then?
You drop the bases and you only have the exponents. Once I've made them the same. I don't want to just like drop them from the beginning, right? Because those aren't necessarily the same if I don't start with bases that are the same. Does that make sense? That's why we had to rewrite in order to be able to drop those bases. Alright. On our next one, do we have the same bases?
No.
Nope. Or are they kind of the same bases?
Yes.
Yeah, we got a 5 on both of them, right? Okay. How could I rewrite a 1/5 so that it has a base of 5?
5 to the negative first.
Yeah, so remember negative exponents, right? Give us a fraction. So are we all okay that 5 to the negative first is also 1/5? So now are my bases the same? Yeah. So now, can I just drop these and set my top equal to each other? Yeah. Which again, we have a much nicer equation. So what do we want to do first?
Subtract 1.
Okay, and we get.
-2.
Okay, and then lastly we
Divide by -2.
and get.
1.
Are you all okay with that? What questions do we have on that one?
So how would we change the fraction back to a regular number, which is a negative exponent? Would we make the 1 on top negative?
How would you change? Are you saying like how did I get from the 1/5 to the 5 to the negative first?
Yes.
Okay. Because basically anytime that I have, I'm just using the property that like 1 over b to like any power. Okay. In this case, this is 5 to the first power, but it works with any power. This always equals b to the negative n power.
Okay.
That's just one of our power rules. And so if this, so say this had been like a 1 over 25, right? That would have been 5 squared. So then this would have become 5 to the negative second instead. It's just this is an understood one, which is why we just have a negative one there. It's just using that power property. So speaking of power exponent properties, what property am I probably going to have to use on this next one?
Fraction.
Fraction, right? Because remember our other property tells us that if I have the nth root of b, remember that we can rewrite that as b to the 1 over n power. So like if I have square root, I can write that as b to the 1/2. In this case, we have a cubed root, so how would we write that? 5 to the 1/3. Now, sometimes though, I had to rewrite one of my bases, okay, but sometimes we actually have to rewrite both sides, and that's okay. On our first two, we should rewrite one side, but sometimes we have to rewrite both of them. How can I rewrite 125 as a base of 5?
5 cubed.
5 cubed. And then remember that if I raise a power to another power, we multiply. So 3 times x just gives us 3x. So now, do we have the same base?
Yes.
Yeah. So I can set my exponents equal to each other. Now, be careful. What do I do to solve for my x?
Divide.
Divide by 3. And 1/3 divided by 3.
1/9.
1/9, right? It is not 1. Which is what a lot of people just see, like a 3 and a 1/3, and they just want to say it equals 1. So remember that I would divide by 3, which is the same thing as multiplying by a third, which is why we end up with 1/9 there instead. What questions do we have on that one? Alright, let's look at our logarithms then. They work pretty similarly. So on our first one, I have a log base 5 of 2x plus 3, and that equals a log base 5 of 3. So, do I have one logarithm on both sides? Yes. Do those logarithms have the same base?
Yes.
Yeah. So, because these are already the same, the only part that we then have to worry about being the same as well is the inside stuff. So we can, again, drop our logarithms and just set the inside things equal to each other. And then we're just solving. So what do we do first? Subtract 3 and we get 0. And then we... So we also get still 0. And that's fine. Sometimes we get 0 as an answer. Now, on our next one, those don't have bases. What's our understood base when we don't have a base? 10. So remember, with our LNs is when it's a base of E. Our log, with no base, is a base of 10. So, do all of them have the same base?
Yes.
Yes. But right now, do I have one logarithm equals another logarithm?
No.
No. Because how many logarithms do we have on the left side?
2.
2. Okay. But did we learn something maybe last week that allows us to take 2 logarithms and squash them into one logarithm? Yes? Yes, it turns into multiplication. So remember that our product property tells us that either one, when we have multiplication, we can break it apart into addition. But it equals each other, right? So I can also take addition and put it together to be multiplication. So now that I've combined those, do I have one logarithm equals another logarithm? Yep. So now we can drop our bases, or sorry, drop our logarithms. And so I just get 10 times x plus 4 equals 20x. I'm just going to move over here so I have more room. What would our first step be to solve? Distribute the 10. So I get 10x plus 40 equals 20x. Yes, no, maybe?
Yeah.
And then what?
You subtracted 10x.
Yeah, I have x's on both sides, so we're going to need to put them all on one side. It doesn't matter which side, but if you move the 10x over, then it keeps it positive, so that's nice. And then last thing, divided by 10, so we get 4. Okay, there we go. So with our logarithms, we're never going to have to like rewrite bases, okay? Like the book and I are not ever going to give you anything that doesn't already have the same base. However, you might have to rewrite them with one of our log properties, either combining with addition into multiplication, or like subtraction into division, or like if I had a 2 on the front, what does that become? An exponent, right? So I might have to like bring an exponent inside my log. Yes, no, maybe. What questions do we have there? Alright, we did our one-to-one property, but like I said, one-to-one does not always work. So we will also sometimes have to do our inverse property. So here I have e to the x. Remember, e is kind of like pi. It is an irrational number. It goes on forever. So if I'm looking at this, I have e to a power. There is not going to be a way for me to rewrite 55 as a basic. Okay. So the only way I would be able to solve this one is using our inverse property. So remember that this is an exponent. Okay. So I can't like divide by stuff or try and take a root or whatever. What I want to do instead is take the log of both sides because that's what's going to undo it. Remind me, which of our logarithms has a base of e?
The natural one.
The natural log. So we're going to take natural log of both sides. Just like I would take the square root of both sides or subtract something from both sides. And the reason that we do that is because, again, natural log and e are inverses of one another. So we're just going to be left with an x equals natural log of 55. Questions on that one? And that would be the exact answer. If they ask you to like find a decimal approximation, you can just plug that into your calculator and see what it gave you. Now, on the next one, what's different? They already have a log, right? So I don't want to take a log if I already have a log. What we're going to do there instead, sorry, we're going to put both sides into the exponent. It's also called exponentiating, just a fancy word. But we're going to put both sides as the exponent of whatever our base is. So here, natural log, again, remember, has a base of e. So I'm going to raise both sides to the power of whatever our base is. And again, the whole reason for that is because our e and our natural log reduce. So I'm just left with x equals that e squared. And again, if we needed the decimal approximation, there is an E button on your calculator. So you can just plug that into your calculator and get the approximation. What questions do you have there? Yeah.
So even if it's in the exponent, they can still cancel each other out?
Because like, my very first one, right? Log base stuff of stuff with the base, that equals x, they go away. But also if I have the base and in my exponent I have a log, those also reduce. It's kind of like if I have the square root of x squared, those go away. But also if I have square root squared, those also still go away. So it doesn't matter which order, right? If they're inverses, then they both undo each other. So same thing here. It doesn't matter if the log is in the exponent or if the exponent is in the log. Does that make sense? Other questions? Alright, let's look at one last one. I think. Maybe we have two more. Alright. We have a little bit more going on with this one. So, before we can decide if we want to use our one-to-one or our inverse, we need to get whatever's being raised to the power by itself. So like right now, notice that our base is 2. I have an exponent, so I need to get rid of the other stuff that is next to that. And then we can decide, can I rewrite my stuff on the other side as a base of 2, or do I need to do the inverse property? So what do we want to do first?
Subtract.
Add 4. And then? So we can rewrite the 2 as a base of 2, obviously. Can I rewrite 15 as a base of 2? Right, 2 squared is 2. 2 to the third is 8. 2 to the fourth is 16. So there's not anything that's going to get me there. So that tells us I can't use my one-to-one property. So we're going to have to use our inverse property. The only difference is this time is what is my base? 2. So when I take the log of both sides, I'm going to use a base of 2 this time instead. Because that is what allows me to reduce with my exponent. So I end up with 2t minus 5 equals log base 2 of 15 over 2. But is my t or my variable, is it by itself yet? No. So I still have to do a couple more things. What do I have to do still?
Subtract 5, or
Add 5 and
divide by 2.
divide by 2. Now, do be careful, because once I've taken the log, I can't put my plus 5 or my divided by 2 inside the parentheses anymore. It has to go outside of my logarithm. And again, if it asks you for the decimal approximation, we could plug that into our calculator if we needed to. What questions do you have? Alright, now let's look at one more. Alright, so on this one, I have a logarithm, but just like my exponent, my log has to be by itself before we can start doing things. So is my log by itself right now? So we have the 2 up front. So what could I do to get rid of that 2?
Into an exponent.
I can. So I get that. Yes? Okay. What's my base here this time? 4. So I'm going to rewrite both sides now as an exponent with a base of 4. And the whole reason we do that is because now my 4 and my log 4 go away, and I'm just left with the exponent. And 4 to the first is just 4. So then what do we do?
Square root of 6.
And we get So we get 5, 5. Now, you also could have divided by 2 here and made this a 1/2, right? So then when you rewrote it, it would have been 4 to the 1/2, but 4 to the 1/2 is also 2, because it's the square root of 2. So either way, you would end up with the same thing. Questions on that?